Hello, welcome back my dear students. In the previous class we have seen Gauss law. Now we will see its application. How we can apply the Gauss law. See, electric field due to infinitely long straight uniformly charged wire. Using the Gauss law we have to find out expression for the electric field. Uniformly long straight, okay. Long straight, infinitely long straight wire we will consider, which is charged, maybe positive or negative. Now we will take positively charged wire. It is infinite length, so it is difficult for me to consider it. So what I will do is, I will draw an imaginary Gaussian surface. Okay, imaginary Gaussian surface is drawn outside or around that wire, that is long straight wire, and we'll consider the length L. R be the radius, this one. Okay, so what we have done, instead of we have considered infinitely long straight wire, uniformly charged wire it is. I cannot use that entire wire and calculate the electric field. So I will draw an imaginary cylindrical cylinder, Gaussian cylinder I will draw around this wire of length L and radius R. Okay. Now, using this, if let the length be L, radius be R. How can I derive the expression, how can I derive the expression for electric field? What we can do? It is a wire, so I can think about the linear charge density. The wire is charged. It is having, let Q be the amount of charge present in the length L. So lambda is equal to Q by L. We know that linear charge density is nothing but charge per unit length. So Q divided by L is equal to lambda. Then I can write Q is equal to lambda into L. Okay, one expression. What is flux? Phi is equal to, what is flux? What is flux? Help me. One is Gauss law, correct. One more. Flux is equal to E into delta S cos theta. So, electric field E into delta S. What about cos theta? Theta is how much? It is acted normally or 90 degree. What it is? What is the amount of angle? What is the angle? Angle is 0. Why angle is 0? Because outward electric field acting is like this. It is normally outward. Therefore, theta is equal to 0. Since theta is equal to 0, cos 0, 1. Therefore, phi is equal to E into delta S. Okay. We also know that phi is equal to E into, what is delta S is nothing but area. Area of the cylinder is 2 pi R L. Area of the cylinder is 2 pi R L. Therefore, I can write phi is equal to E 2 pi R L. According to the Gauss law, phi is equal to Q by epsilon naught. But Q is equal to lambda L by epsilon naught. Substitute 1 in 2. Then, can I write E 2 pi R L is equal to lambda L by epsilon naught. L gets cancelled and the remaining is E 2 pi r is equal to lambda by epsilon naught. Or else, if I take these terms other side, electric fields expression we will get. That is, E is equal to lambda by 2 pi epsilon naught r into n cap if it is vector. Otherwise, E is equal to lambda by 2 pi epsilon naught r. What we have done? We have considered infinitely long, straight, uniformly charged wire. We have to derive this expression for the electric field using Gauss law. So we will imagine a Gaussian cylinder or Gaussian surface around this infinitely long straight wire of length L, radius R. Q be the charge present in the length L. So linear charge density lambda is equal to Q by L. And then I can write Q is equal to lambda L. We know that phi is equal to a number of electric field lines cutting the area element normally. So E into delta S cos theta. So phi is equal to E delta S. But theta is nothing but 0 here. Cos 0 is 1. Therefore, phi is equal to E into 2 pi R L. Because 2 pi R L is nothing but this one. So, area of this cylinder is 2 pi R L. So, phi is equal, we know that according to Gauss law, phi is equal to Q by epsilon naught. But Q is nothing but lambda into L into by epsilon naught. So, let us substitute equation number 1 in 2. So, we get E into 2 pi R L is equal to lambda L by epsilon naught. L gets cancelled. So, E is equal to lambda by 2 pi epsilon naught R. In the vector form, I can write E vector is equal to lambda by 2 pi epsilon naught R into n cap, where n cap is a unit vector. So, this is how you can write. Very, very important for 5 marks. Then next, we will move towards one more application. That is, again you have to find the expression for the electric field, not due to this infinitely long straight wire. We have to use the plane sheet using the Gaussian law. Using the Gauss law. Electric field due to uniformly charged infinite plane sheet using the Gauss law. So for this, what you have to do is, we will consider infinite plane sheet. Okay. One plane sheet we will consider. We cannot derive this derivation for infinite. So we will consider one Gaussian surface, imaginary Gaussian rectangular surface, which is paraboloid. That is, we are sending it from the center. Okay. Okay. So this itself is coming out. So like this plain sheet we are inserting. Okay. Let us, this and these two surfaces are outwards. This is inside. Okay. Now it is placed inside the uniform electric field. Uniform electric field. So there are two surfaces which is open, and from one of our derivation, that is what we have done, electric flux inside without any charge is 0, correct? Okay. Now let us consider if there is charge also it is 0, because inside the angle is acted outwards. The normal drawn to the surface is acting outwards. So therefore, what we have to do is, since the normal is acting outwards, at the center, that is if I mark it as third region, then at the third region, the flux is 0. So we will find out the electric flux only to the two surfaces, that is first and the second surface. For this first and second surface, what we have to do, electric flux to the first and second surface will get added up. Why it will get added up? Because electric flux is acting parallel. Here electric flux, if this be the direction of the electric flux, here this is the direction of the electric flux. So therefore the electric fields are added up. Therefore total electric flux is, what is the total electric flux here? Phi is equal to, what expression we can use? Phi is equal to, we know that phi is equal to E into delta S cos theta, but it is theta is equal to 0. So therefore I can say, if since theta is equal to 0, phi is equal to E delta S. Now instead of delta S, let me take the area be A. Delta S be equal to area, that is A. Then the expression will be what? E into A. Sheet, it is a plain sheet. So uniform, I'll consider the area of the sheet. So can I write sigma is equal to surface charge density is equal to charge per unit area. The charge per unit area is nothing but Q by A is nothing but surface charge density. Then can I write Q is equal to sigma A? If it is so, we can write, we know that the Gauss law states that phi is equal to Q by epsilon naught, where Q is nothing but sigma A by epsilon naught. If we substitute this expression, but we cannot directly substitute this expression there. Why we cannot substitute in the place of phi is, this is for the first one. For the second surface, again for the second surface, it is also one and the same, E into area, because this is one and the same. My diagram is not that good, you know how I draw. So I request to draw it neatly. So phi 2 is equal to E into A. If I add first one and second one, then I'll get 5. 5 1 plus 5 2 is equal to 2EA. Therefore, substitute, this is a star. Substitute 3 in star. So if we substitute 3 in star, what we get? 5 is equal to, in the place of 5 we have to write 2EA is equal to sigma A by epsilon naught. A gets cancelled. This implies E is equal to sigma by epsilon naught. Sigma divided by 2 epsilon naught. Or in vector form, if you want, it is n cap. Understood? What we have done? We have considered a uniformly charged infinite plane sheet, and we cannot directly use that for deriving. We have to draw a imaginary Gaussian surface. So, which is rectangular in shape, it is paraboloid, it is kept inside. From inside, we are sending it like this. So, from the center, it is passing like this. Like this. The diagram is actually like this. This is a plane sheet. Inside this, we are making some hole and we are sending like this. It is coming out like this. So, at the center, whatever the electric field is present, the total flux is equal to 0 because the angle flux theta is equal to 90 degree. Therefore, phi is equal to 0. So, only at the two direction you can consider. Here it is outward, there also it is outward. So, therefore, phi is equal to EA. Total it is 2EA here. Sigma is equal to Q by A. What is sigma? The sigma is nothing but surface charge density, Q by A. So, Q is equal to sigma A. Therefore, we know that according to Gauss law, phi is equal to 1 by epsilon naught into Q. In the place of Q, I can write sigma A. Therefore, sigma A by epsilon naught. Substitute 3 in star, we get this expression. Therefore, E vector is equal to sigma by 2 epsilon naught into n cap. These are the two derivations, very, very, very important for 5 marks. Then, actually, to draw this diagram, one simple method what I can say help you is, see, one plane sheet we have to consider. Okay, this is slant like this. Okay, now I have to send one more slant or a bent sheet. Correct? Like this. This bent sheet, when we placed it inside, it has come out like this. That's all. No, or you can also draw it like this. See. This is easy. This is better. So what you have to draw? How to draw? This one center, what you have to draw? See, with the color chalk. At the center you draw it like this. Then from this itself, you take one box. Like this. Okay. From this one. Outside like this. Okay. For that one. Here. from this side. Okay, then from this one. Add these two over. This is how you can draw. Okay, so this is how you can draw and write this E1, E2 and all. Fine. So 2 derivations we have done in our today's class. After writing the notes, please close your book. Write the derivations without seeing. Learn the derivations because these derivations are very, 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 very important for 5 marks. Okay? Thank you.